Welcome once again to our ICT lectures. So in today's lesson, we are going to take a look at what computer architecture is and the various system buses. So as a matter of fact, the architecture simply refers to the structure of a computer and how the communication happens within the computer system. So maybe we can break it down by looking at this particular diagram further. So you can see those particular lines showing how data is being transmitted within the architecture of the computer. So to understand more about this, kindly feel welcome to this particular lecture, and I hope you're going to enjoy this particular lesson. All right, thanks. Hi Lana, hello and welcome once again to Lana's Coach. So we're going to look at what is a computer bus, commonly referred to as system bus. So we have different categories of buses that we can discuss as far as computers are concerned. But today we are simply going to understand the various types of system buses that we have. Of course, we are going to introduce the concept of a bus and understand what is a computer bus. Now, as you can see, there's a diagram here. Actually, it's a background image showing some kind of components, right? Now, these components are actually integrated together under one particular circuit board known as the motherboard. So the motherboard actually hosts different computer components that needs to communicate together. So that's the need of a bus. So a bus is like a wide road or a narrow road. So the wider the bus, the more data can be transferred from different components, or the faster the data transfer rate. The narrower the bus, the little or few data that can be transmitted from one component to the other. So we're going to identify these particular main system buses and actually identify their pros and cons, right? So a more clear picture is this one. This is a motherboard showing the various components. So you can see the south bridge, north bridge. Now all these components, ladies and gentlemen, need to talk to each other. And for the communication to happen, we need a bus, right? So a bus is a set of wires, or rather is a way of how different devices can push or rather pass data from one, or pass signal from one component to the other. So ideally, we can't exhaust talking about the different types of or the different components of the computer motherboard, but you're going to identify, like for example, you can see the PCI slots. This is one of the system buses that we're going to look at. Then we have the AGP. AGP is another system bus that we need to understand. And of course, we have the processor bus, the one that allows the processor to communicate. When talking about the system bus, also we need to factor in the south bridge, right? So this is a chipset that actually ensures that there's a well coordination of communication flow. And of course, you have the north bridge. North bridge is normally closer to the processor. So it's very important to understand these crucial system components when you're talking about communication. So as I'd mentioned, the components inside your computer talk to each other in different ways. And of course, we have the internal components I've already mentioned. You could see the memory. You could see we have the various connectors, the I/O ports, right? I/O ports simply means the input/output ports at the back of the computer. So all these creates a need of having some kind of buses, and that's why we need to understand the various categories of computer buses. So as I mentioned, a bus is a set of wires that is used to connect the different internal components of the computer, right? Ideally, because we need to transfer data as well as the addresses amongst them. So apart from the system bus that we're going to look at, we also have the data bus. Ideally, the main function of the system bus is to ensure that data is transmitted. So data bus here is used to transfer data amongst the different internal components of the computer. So the data bus here can be determined by the width. That's why we started having the 4-bit data bus system. We had this 8-bit data bus system, we came to a 16-bit, 32, 64, and more advancement has brought forth 128-bit bus system and so on. And then we have the way of allocating this data in different memory addresses. So when we read and write data in these different memory addresses, we require the address bus. So kindly factor in these other buses apart from the ones that you're going to mention. So to bring this particular discussion to the right path, let's look at this particular diagram. So you can see that the data is being transmitted from different parts, more so the input devices to the main memory, and of course you have the control mechanism that has the dotted lines. All these lines, be it red or blue, represent the data bus of or how the data is being transmitted from one part of the computer to the other. So ideally this is a kind of how the processor functions, and this could represent one system bus known as the processor bus, of how processor actually fetches data from the main memory and coordinates the instructions that are being pushed from the input devices, and how these particular output devices receive these particular signals. So this is ideally how we can consolidate the understanding of the data bus. But talking about the system bus, right, because this is the main agenda of having this particular tutorial. So the system bus is actually the heart of the motherboard, right, that allows the various components to send signals between themselves. So as you can see from this particular diagram, you can see I've already mentioned the processor system bus. As you can see, it is the bus that coordinates all the activities within the processor between the processor, the main memory, and the input-output devices. The other type of bus that we're going to discuss is the AGP, right? Accelerated Graphics Port System Bus, right? And of course, we have the commonly used system bus known as the PCI system bus. So Peripheral Component Interconnect is another one that we're going to look at. It is the new version that most computers use. And of course, you have the early version, which is the EISA system bus. So these are types of system buses that we need to understand, because someone is going to ask you within this particular motherboard which kind of system bus is there. So ideally, we have the three main system buses, that is the EISA, the PCI, and the AGP. And of course, you're going to mention others, but these are the most crucial ones, right? So let's look at the most outdated, right? The EISA bus, known as the industry standard architecture. Points to take home from this is that it had some key performance issues because of its speed, right? So it couldn't actually support the new devices that are being brought forth. So we had to replace this EISA bus. Of course, it had the transfer rate of 8 megahertz, right, per second. It could only support 16-bit bus width. We also had the 8-bit bus width. So this one could not really give more. Of course, more. It couldn't support the many devices that are being used nowadays within the computer. So it had to be phased off. So we had the 8-bit EISA bus. We had the 16-bit, right? So the speed was the issue. Then we have the PCI, Peripheral Component Interconnect. So it's more popular compared to the EISA. The speed has improved. As you can see, it supports up to 33 megahertz. So it has a 32-bit bus address system. It can also handle the 64-bit bus system. So the good or the advantage of the PCI is that it offers the burst mode, right? So it has enhanced the performance generally on how the input and output devices communicate. It can transfer information very, very fast. It also offers high bandwidth options, right? So you can have speeds up to 66 megahertz, of course, even much better than this. So these are the advantages of the PCI. It improved performance from the EISA option. So it also supports newer devices that uses the plug and play, right? It offers additional expansion slots, right? So if you had to add different cards to your system, PCI provides that particular option. So yes, compared to the EISA, PCI actually is the most recommended for the current computers. And of course, we have the accelerated graphics port. Now, why did we need to have the AGP? Now, AGP was brought to actually support the video or the graphics component of the computer. So it was established that the processor alone could not handle a lot of the video processing requests or the graphics requests, right? So there was need to have a standalone kind of bus that is going to handle all related video and graphics process requirements, right? So that it could not overwhelm, or it could actually relieve the main processor from these additional processing activities. So yes, it is more or less the same as the PCI, but it was meant for video related processing work. So with the need of the video bandwidth, so there was the need to bring on board this particular bus. So it's commonly referred to as a port, but ideally it is a bus. So this was manufactured by the Intel. Intel are the people who came up with it. So I've already mentioned that the issue of video memory brought the need to have this particular AGP. So when we talk about the accelerated graphics port, we say that it had additional advantages that was brought forth as far as the introduction of the video processor is concerned. So ideally, when you have PC that requires use of graphics or playing of games, right? So AGP brings this particular advantage. So it isolates the video subsystem from the rest of the PC. So AGP is a game changer when it comes to use of video or playing of games. So here it also has almost the same speed as the PCI, but ideally this is just isolated for the what? For the video memory. So the speed here is the same as the PCI, like it has the 33 megahertz, right? Now, we also need to understand other different buses that were brought forth, but they came shortly and they disappeared, right, because of their limit. So this is an old motherboard, as you can see. Of course, it's an extended technology motherboard. It only runs on the EISA bus, 8-bit. So this particular motherboard supports a very slow bus system known as the EISA. So you can see also the jumpers the configuration were to be done via the jumper, and it was only limited to 1 megabyte of memory. So this is an old technology, right? Then also we have the processor system bus, which actually coordinates the communication between the various components with the processor, right? Normally it is close to the south bridge or to the north bridge, so we call it the front bus system. So primarily this coordination of processing requirement happens between the bus, between the processor and the north bridge and the main memory and the cache memory. So you have to understand that within the processor there are closer components such as the main memory and the cache memory. Now these are type of computer memories that allows the processing of instruction. So cache memory stores frequently accessed instructions, whereas main memory is a bit far from the main processor. So this brings on board the need to have a processor system bus. So ideally, As we talk about the different types of buses, remember that the process system buses offers high speed because of the very many coordination between the processor and the connected components. So we have also talked about the AGP system bus. Normally it has a very funny color. So you can see it is a brown color, right? So it's used for video and it's connected to the North Bridge. So the North Bridge is a chipset that assists the processor to indirectly communicate with other components, more so the AGP system bus. So the North Bridge here assists the processor in coordinating other additional processing activities. So we also had the PCI system bus, normally white in color, as you can see them. So we have already seen that they offer 32-bit bus, and they are the newest. Yeah, you can say they are the newest within the computer world, and they can always offer greater speed. We also looked at the EISA system bus. You can see they are black in color, right? It only supports 8 bits and 16 bits bus, and they are no longer supported in the newer motherboard. So we can always refer to them as obsolete system. But ideally, there are other computers that are still using the EISA bus system bus, right? So we also need to understand the expansion buses that you can always use, right? So apart from the EISA, we had different other category of ISO or expansion of IO buses. So ideally, apart from the EISA PCI, we also had the MCA, we also had the VESA, we also had the PCMI, the PC card. We also had the EI or EISA card. We also had the VESA. Now, these other additional expansion IO buses are part of the system buses, but they are obsolete in that they are overtaken with time in terms of speed and the processing capabilities. So we'll just mention them, but ideally they are not used within the current computer system. So we talk about we've already looked at the EISA. You can see it is black in color, and these are the expansion cards, right? So the expansion cards that can be used within the EISA bus are as shown. You can see the one that supports the 8-bit and the one that supports the 16-bit, right? So they're normally black in color. It's very important to identify. And we have the micro channel, the MCA. This is another expansion card that was brought forth, but they were not compatible with the EISA cards. So this was a product of the IBM. So it used the 16-bit and the 32-bit card. Sorry. Then we also need to understand that it's brown in color. You can identify it, but rarely will you find it in the current computer system. We also have the extended industry architecture. Now this one was to support or to advance the EISA requirements from 16 to 32-bit, but it was not actually viable, or it didn't work well with the current computer system. So it came to be obsolete because there was new bus that was introduced, and that was the PCI, right? So the extended EISA didn't actually work for long. So it came for a short while and it left the market, right? Then we had the video, Electronics Standards Association. This is another card. It's known as the VESA. Now VESA came to actually carry out the functions of the AGP, right? So it offered some kind of the video subsystem processing requirements. So again, it faded very, very fast because of the introduction of the AGP that provided the full processing requirements of the video and the graphics for that matter, right? So VESA is also another bus but that came and left very, very fast, right? Of course, the newest bus that we are using right now in our systems are the PCI. I've already talked at length about the PCI card. So you can use it to connect our network cards. You can use it to connect our the modem and so on. So there are a lot of cards that you can use for the PCI. We also had the PC card, right, that was brought to give the plug and play room, the components that were using plug and play, or the hot swappable components. It also came, but it was quickly phased out due to the introduction of the USB. So USB came and the PC card left. Of course, we are still using the PC card, but not in all the devices. We also have the AGP, you can see, right? So AGP was an Intel product that actually gave breadth to how the various video subsystems could be handled. So ideally, these are the various types or examples of the system bus. So just to recap, what we have looked at is that we have different buses. We have buses that allows us to handle the address system. We also have buses that allows us to handle the data transfer. And we have the main system buses that we have already looked at. Example, we have looked at the AGP, we have looked at the EISA, and of course we have looked at the PCI cards. So of course we have also mentioned the other ones that such as the VESA, EISA. We have also looked at the PC card, which are no longer used as per now. So the currently used system bus or the system card is the PCI. So should you find this information useful, ladies and gentlemen, kindly always feel free to subscribe.